It's an honor for me to introduce Professor Jason Hong from Carnegie Mellon University. Most of us know his work on privacy and security, such as the work on the privacygrade.org, and his work on computer-human interaction.
We got one.
We got one over here as well.
Okay.
His work has been recognized in a number of venues, but for us, what is important is that he's going to talk about something that we care deeply at Google about, privacy and mobile, which are both our very strong priorities, and I'm personally very excited about the work that he's going to talk about, and I think you too. So thanks for coming. And
all right, thanks. Oh, okay. Yeah, so this is sort of like a last-minute conversion from PowerPoint to PDF, so if you see any weird colors, that sort of explains it. So thanks for having me here. I want to talk about some of the work I've been doing with analyzing the privacy of these Android apps and just give you sort of a sense as to what we've been up to, as well as some kinds of reflections as thinking about privacy in general and what kinds of things we can do as a community to help improve things. And I just want to sort of give like a broader overview of what our research team's been doing. You know, I think in the near future, our smartphones will pretty much know everything about us. They're going to know if we're depressed or not. They're going to know what our transportation needs are, and probably even what information needs we have too, before we even know what those are. And I think there's two big reasons why I'm making this statement. First of all, smartphones are incredibly intimate devices. Here's some fun facts I found about millennials. Like 83% of the millennials sleep with their phones right next to them, and primarily using it as their alarm clock too. Also found another stat saying that 90% of these millennials check the first thing in the morning their smartphones. And 1 in 3 even admit to using them inside the bathroom too, which is a little bit gruesome, but you know, ask no more questions. And you have to remember, this is only just the number of millennials who admitted to doing this too. The other thing is that it's not just the smartphone devices that are intimate, but also the data that's intimate. So these are just screenshots from my own smartphone. And you know, if you had some of these algorithms, you could guess a lot about this individual, about me here. So like who I know, who I call, who I text. Even just on the who I call part, you can even infer easily who's my spouse and what the relationships are with other people. And that's some of the past work that my team has also done too. And also, where I've been going, where I go to using Foursquare and GPS data, and also all this different kind of sensor data too. And so I think we actually are at this major inflection point in history. We're going to soon be able to analyze all of human behavior at a really unprecedented fidelity and scale. And this is going to enable us to build incredible new kinds of services for healthcare, transportation, and sustainability, but only if we can really manage all these kinds of social issues too. And so this is where the privacy part comes in. And these are just a few examples, screenshots from recent news articles too. So about Facebook Messenger app, employer being sued for GPS tracking, and also on NPR talking about all these fitness trackers and someone on your wrist, sometimes on your phone too. And so here I wanted to focus specifically on apps, because this is sort of the the main kind of dissemination of how we use all these smartphones right now, the main kind of function of how we can make use of all the functions there. And so Pandora, a few years ago, was actually under federal investigation for collecting too much data about its consumers. So, for example, Pandora was sharing location data, gender, unique phone ID, and phone number with dozens of advertisers without making it clear. And I actually don't know what the status of that is. This is even a few years ago. Path and Facebook, they uploaded your entire contact list to their server without your knowledge too. And this is a really huge surprise. Even to me, I study this stuff, and it wasn't even clear to me that this was going on too. Fortunately, Path stopped it. It's not clear to me whether Facebook has stopped doing this. But at this point, they also already have the data, so it's sort of already a done deal. But this is not unusual too. So there's a whole bunch of apps that have unusual permissions. So for example, there's a game here that wants your location data, microphone, and unique device ID. There's also a flashlight that wants location data ID, network access, and unique device ID, and even a Holy Bible app that wants this too. So even supreme deities need your help to figure out where they are. So my team's been doing is we're looking at how to do how we can improve the state of the art here. I'm going to give you sort of an overview, a really summary of all the work that our team's been doing here. So first I'll start out by talking about some interviews and surveys my team's been doing with app developers to try to understand what do they know and what their incentives are. Next I'll talk about Privacy Grade, this website that we developed to analyze all the privacy of these apps. I'll talk a little bit about what we've been doing with text mining to try to understand what's been going on with these apps as well too. And lastly, I'll end up with a little bit of a few reflections as to where my team's going next and sort of my philosophy on things too. So for the first one, what do developers know about privacy? We did interviews with 13 app developers and surveys with 228 app developers to understand what kinds of tools they use, what their knowledge is, what their incentives are, and are there any good points of leverage. There's actually more details inside that paper if you want to see more, but I'm just going to give you a quick 2-slide summary of this. The first one is that third-party libraries are really problematic. So I'm sure you all know, the Android apps, basically there's a whole bunch of different components to it. So some of the components are made by the developers themselves, and some of them are made by other people. So it's sort of like Lego pieces that you're grabbing from other places that offer you useful functionality. And the problem with this is that, it turns out that a lot of the developers don't understand the behavior of these third-party components at all. So, for example, a few of them didn't know they were using libraries, and the reason we're saying that is because they had very inconsistent answers about the behaviors of these kinds of components that they were using. Some of them didn't even realize that these libraries were collecting data. They just said, well, we can't compile it and run it without location permission, so we're just going to add it in, and now it works. And even if they did know that it was collecting data, it was not always clear to what extent that these third-party components were collecting data. So here's one quote from one participant. If either Facebook or Flory had a privacy policy that was short and concise and condensed into real English rather than legalese, we definitely would have read it. But it's just like reading an actual privacy policy for all the components that you're using, and the developers found that very burdensome. The next part was developers actually don't know what to do either. So they knew that privacy was a problem, but they had the awareness, but not the knowledge or necessarily the motivation to actually operationalize on it. So there's very low awareness of existing privacy guidelines. So there's like the FTC guidelines and the state of California guidelines, but often they didn't even know this. And often they would just ask others around them, what should I do, or just use search engines to try to figure out what other people were doing. Developers also had low perceived value of privacy policies. So they viewed it mostly as protection from lawsuits, as you can see in this quote here. I haven't even read our privacy policy. I mean, it's just legal stuff that's required, so I just put it in there. And so reflecting on this, and I'll talk a little bit more about this at the end, but just here's sort of a preview. Developers really need a lot more help here in general. So there's a lot of best practices for security. So we all know we should be using SSL, we should be hashing our passwords, we should be using lots of randomization for things, we know what kinds of common attacks there are. I think it's less clear as to what the best practices are for privacy. And it seems to vary for different kinds of data that you're collecting too. So for example, some of the developers know about the PII, personally identifiable information, but even then it wasn't always clear what counted as PII for the smartphones. Developers in general also have lots of problems they need to deal with too. So there's just the app functionality, which is the most important part, but how to deal with all the bandwidth, so making sure they're not killing the bandwidth on your phone, making sure they're not killing your battery, how they can make money off of this. So privacy is actually fairly far down the list. So we need to try to find ways of making developers' lives a lot easier too. And this is going to be a theme I'm going to echo again throughout the talk. Okay, so for the next one, we'll talk about privacy grade website that we've been creating. If you guys have short questions too, feel free to ask. Otherwise, we can keep the longer ones to the end. So this is a website that we've created to try to improve transparency of what the behavior of these apps are. And we're also aiming to assign privacy grades to all 1 million Android apps. Here's sort of the preview of what the website looks like right now. You can also go to the site. And so as you can see, we assign grades from A through D to all the different apps. We stopped at D primarily because we were worried about getting sued. It also, just to let you know, it took us about 5 months to get this through the CMU lawyers, which I guess for me is pretty long, but I'm guessing for a corporation was actually pretty good. So we stopped. It took about 5 months, and here's sort of an example of what it looks like for a single app. So for the drag racing app, we assigned this one a D, and here at the very bottom, you can see what the sensitive permissions used by this app are. So if we scroll down, you can actually see some more of the permissions. And so basically, it's 3 different columns. If I just go back, we have the permission, which is already known from Android. We have what it does, which is our explanation of what's going on, which again is fairly straightforward. The new part that we're adding in is the why. So this is our inference as to what the app is doing with your data. Okay. And here you can see it's doing a lot of different kinds of things with your data, or it's potentially doing lots of things with your data. And at the very bottom, we also describe what third-party libraries are used by this app. So we just showed this. Here you can see all the third-party libraries that we could easily identify using this. And so we have Flurry, Chartboost, Millennial Media, and so on. And we also give a description based off of what we grabbed from the website as to what this library is doing. And this is really our main point of leverage, is to analyze the libraries to make our best inferences as to what the app is doing with your data. And so this is really the heart of the idea here. And this is actually one of the most important concepts in HCI too. It's known as a mental model. So on the left side is a Nissan Maxima that my brother used to drive. And it turns out he was actually driving it wrong for over a year before I pointed out what he was doing wrong. So just wondering, does anyone here have a guess as to what he was doing?
He was stuck in third.
Yeah, my brother was actually driving in third gear rather than fourth gear for over a year. And so one time I looked at it, it's like, yeah, something's not right here. And so yeah, and this is what the mental model is, which is you think something works one way, but in reality it actually works another way. And as you can see, if your expectations are not matched with the reality, then you have problems in operating things correctly. Whereas you can see the one on the right side, there's no way you can get it wrong because the mapping is very, very clear. Now, I'm also the younger brother, so I have to make clear that my brother's a very smart person, especially since this is recorded, I have to say that. And in fact, you could also argue that my brother's smarter than me because he also drives a Tesla Roadster and I don't. Okay, so this is sort of the heart of the idea too. So if we can figure out the mental model of these apps, then we can also try to understand what the potential privacy implications are. So what we're doing is we're using crowdsourcing to compare what people think an app does to what it really does. So for example, most people might not expect this motorcycle game to use location data, but in reality it does. And so we consider that gap to be a privacy problem. Whereas if you ask people, does Google Maps use location data, everybody says, yes, it's obvious. So we consider that to be less of a privacy problem. So this is not complete and comprehensive, but it's also a good way of operationalizing the problem. So for example, some of these services might be doing things on the back end with the data, which we can't easily look at. So this is the first study, and it was also done by Jialiu here, so you have your resident expert. And also, I should say, you guys are very smart in hiring her. Let me know if I can further embarrass you. And this is the results that she had from the initial study, which I thought was actually pretty good. So this is what, usually when studies work on the first try and it's better than you expect, I usually think that's a pretty good sign. And so here you can see the apps and what people's comfort levels were between -2 and +2. So people looking at location data, maps using location data, were very comfortable with, and same with Gas Buddy. But Brightest Flashlight and Toss It, which is a game they're very uncomfortable with, after asking that question, do you expect this app to use location data? And here's also a summary screenshot of some of the user interfaces that Jialiu also created too. So for example, for the Brightest Flashlight, we're organizing things by level of surprise. So for example, 95% of users were surprised this app sent their approximate location of mobile ad providers. And on the right side, you can see the same thing with dictionary.com. People were surprised that it used the phone's unique ID. One thing that we've also found was really interesting is the one that's highlighted there. 25% of users were surprised that this app sent their approximate location to dictionary.com for searching nearby words. So this is one where we saw a really interesting contrast, where people were very surprised to find out that dictionary.com used location data at all. But when we explain what it was for, then the comfort level actually, and the surprise level actually goes down, the comfort level goes up. And in case you're wondering what it's doing, you can actually search for what words people near you are looking for. And so one funny kind of incident that happened is one time I was in Washington, D.C., and I was doing an interview with CBS News, and was showing the journalists this app. And lo and behold, what words were people searching nearby? It turns out in Washington, D.C., it was corruption. So, sort of, it's like, first off, you don't know what that is. And secondly, you're actually looking it up there. Okay, so you can ask Jialiu for more details, or you can look at the research paper. But then the next question here we're looking at is, how do you scale up this analysis? So it took us about 2 weeks to analyze 56 apps, and only simple math will tell you this doesn't work very well. So the next idea we had is, can we combine crowdsourcing with static analysis to analyze the App Store? So again, we're using libraries as the main point of leverage here. And because they give us a little bit of insight as to what the purpose of the permission request is. So for example, a location used by Google Maps library versus an advertising library gives you a hint as to what's going on with it. And so here's some more of the stats that we have in privacy grade. So you can see that there's a whole bunch of really popular kinds of libraries. This is sort of ranked by the number of apps that are using the library. And you can also see the different categories that we created for these as well. So targeted advertising, social networking, utilities, and analytics. There's a long tail of distributional libraries, so we just focused on the top 400 libraries. And so there are definitely things that we don't capture, but for the most part, I think we capture the vast majority of these kinds of libraries and their behaviors. And so what we did is we crowdsourced people's expectations of a core set of 837 apps. So an example question would be, how comfortable are you with drag racing using your location for ads? So it's a little bit like Mad Libs, if you've ever played those games, where you just sort of fill in the blanks. And we asked 20 people per question these as well, too. And here's the heart of how privacy grade currently works, is that we have this predictive model that tries to guess how comfortable or uncomfortable people are based on the behavior. So we basically aggregate the results across all the different apps and to try to understand the behaviors. So for example, if you look at the x-axis here, we have internal, ads, analytics, and SNS. So SNS is social networking services, analytics, straightforward, ads, straightforward. Internal, in retrospect, was probably not the best name we could have come up with because it sounds like it's just only using the data internally. It just means that's the custom code that we can't analyze easily what it's doing. So we'll probably rename that in future work. The y-axis, we have different locations, phone state, contact, SMS, and account usage. So one concrete example here, you can see that using location data for social networking in the very top right corner right here, we have 0.28. So that means that people are generally neutral to mildly comfortable with using location data for social networking. But if you look at for ads, you can see that it's negative 0.3. So that means people are less comfortable with that too. And the blank spots here are basically cases where we didn't have a lot of data. So for example, SMS used for analytics is very kind of rare scenario. Here's the overall stats on privacy grade. And this is as of April 2015. This is when we did our most recent crawl. No sensitive permissions means that we assigned it an A+, and so you can see about 6.8% of these apps we assigned an A+. The other grades are set at quartiles of the entire grade range, so if you just do the really simple things. And the big surprise for me is that if we just did this simple approach, that the vast majority of apps actually get an A. I was actually very, very surprised at this. I thought it would be the other direction, but actually it turns out that not that many apps really use that much sensitive data. Then we have B's, C's, and D's, as you can see there too, so roughly 3 to 4% as well. Now, this is a really fun one here, which is how have the grades changed in between the two crawls? So we did a crawl back in 2014, so October 2014 is when we finished that first round of crawl. And then the other one is what the current grades are based on the April 2015 crawl. And so what I'm going to highlight here are some of the interesting parts. So as you can see, if we just highlight the axis here as to the identity, so there's a lot of apps that still have this exact same grade in the previous crawl to the current crawl. Okay, so this, as you might expect, the interesting part is this 83.52 for B to B. You can see that's the lowest one. And so if we go to the next part, which is how many apps have actually improved their grade, this is actually pretty good. It's actually better than I thought it would be. And in fact, you can see the biggest one right here is apps going from B to an A, so 10% there. So I don't know if I can claim credit for this. I'm happy to immodestly claim credit for it. But I think this is actually a pretty good sign. That means that some of these app developers actually are interested in privacy, and I'm hoping that we had some influence on this too.
Well, or user expectations changed.
That could also be a possibility as well too.
Is it possible because of the change of the permission model in Google Play?
Yeah, it's definitely possible. The thing is that we don't have the root cause analysis, so it definitely could be. We don't know for sure, but I know for sure that there's at least one developer that has changed their behaviors, which I'll talk about in a second. This is the other one that I find really interesting too, and I don't have a strong analysis here yet because it's sort of beyond what we can do right now. A lot of the apps were actually deleted, and this is across the board. Even with apps with high grades were removed as well too. So you can see that for A+, about a third of the apps that we had given A+ were removed between the two crawls. Interestingly enough, the C's and D's had the highest one with about 50% of those removed. I'm actually not sure why they were deleted, whether it's because of the privacy issues, because they were low quality, because they were too spammy, or some other things. I do know that it was much harder for me to find bad examples over time. So whenever I talk to journalists, I'm always trying to find more examples, and it just becomes a longer process every single time. Our team also suspects that some of these apps were re-uploaded to under different developers. So the most spammy ones, we actually do have the star ratings for these, so we could probably just look at how well is this correlated with the star ratings and see how many of those are removed as well too. But yeah, right now it's just conjecture. So we do have a mobile app now. So we just created this. One of the undergrads has created this. What it does is it scans the apps you have on your phone and just retrieves the grades from our site using a simple JSON protocol that we created. We just now need to submit this to Google Play. I have to admit that it's a little embarrassing that I did upload this, and then it was actually removed by Google Play because we're scanning the apps, and we didn't have the notification saying that it scans the apps on your phone. So we've actually already added that, and now I just need to do the last checks and before we upload it again. And hopefully it won't be removed this time, or hopefully our account won't be blocked. But yeah, so this will exist. This is actually the most requested feature from all the people who give us feedback is there a mobile app that we can use? Another thing we've been doing is also looking at how to improve the grading model. Right now, as you can see, the grading model we use is actually very simple. It's just a very simple linear model. There's another person, his name is Song, who is developing a richer machine learning model. And what we've been doing is just doing lots of feature engineering here. So for example, we grab all the Google Play metadata and text description. We do app subjective quality, so star ratings, number of downloads, and so on. We're looking at app quality. So does this, and these are weak proxies of quality, I should emphasize. So for example, does this app have a website? Is there a privacy policy link? How many resource files are there? How big is the app? How many activities there are, and so on. And then there's also privacy-related features. And again, these are weak proxies. Some of them are weak proxies. So the URLs in code and popularity of permission purposes. So by permission purpose, I mean like permission is location and purpose is ads. So by the popularity of it, location for ads in games is very popular. And so generally, you might guess that that's lower concern in general. Whereas location for ads in business apps is very uncommon. So the concerns there might be higher. We also did a lot more crowdsourcing, and we have a lot more data too. So 16,000 ratings versus 7,000 in the previous studies. And here's sort of the preliminary results. We still have some more analysis that we're doing, but just for the Pearson correlations are just like, well, it's just think of it as a correlation. As on the left side are the negative ones, on the right side are the positive ones. So there's some unusual cases. So for example, on the left side, installation size, the larger installation size, then it seems to be lower privacy grade. Audio count too, the more audio files too, that it also seems to have a lower privacy grade. We're not sure what that means. But there's other ones that do make sense too. So for the more mobile analysis you have, the more targeted ads you have, then it's also worse too. Oddly enough, some of the app quality features were also positive as well too. So as you can see, the positive ones are much larger than a lot of the negative ones too. So for example, the number of receivers you have, your permission count, the permission, which is also unusual, permission popularity by category, layout XML, and number of pictures you have too. So these, again, are just sort of the weak correlations, and this is not really part of the model because the model is going to be nonlinear in this case. So we're looking at how to do some of these expectation maximization approaches to improve things. Okay, so there's a lot of limitations to our current approach as well too. So privacy grade works for most apps, but for the most popular apps, it probably does not work as well because the most popular apps have a lot of custom code inside of them. And so that's what I'm going to talk about next is, can we also guess what things are doing inside of the custom code? We also didn't analyze the back end because there's no easy way to do that right now for us. We also only analyze free apps. We found out there's limitations on downloading apps too, so that we can only download about 20 of these paid apps per day. And so there's no easy way for us to analyze those, unfortunately. We also assume that most libraries have just one purpose. And we did an analysis of this. That's true for about the vast majority, about 350 of the 400 libraries we looked at. Well, that's generally true that there's one major purpose. However, we discovered there's a few of these apps or these libraries that do have multiple purposes. The most common one is analytics and advertising. So we've seen apps that used to do just advertising, now they're doing advertising and analytics and vice versa as well too. So we might just create a new category for that one. In terms of the impact, this is also a little bit of a preview of how, my thoughts on how we can influence privacy practically. Even though privacy grade looks like it's for end users, it turns out that, we weren't really targeting end users. We were really targeting the journalists, government, and developers too. And so with respect to the journalists, New York Times, CNN, BBC, and CBS have been helping to popularize this, so that's been very helpful. For the government, some of our earlier work helped lead to FTC fines, and I also managed to scare the bejesus out of a lot of these congressional staffers, which might be good too. So trying to tell them about these third-party libraries and what all the data is being captured about them. And again, there's at least one developer, and it's also a very pretty popular developer too, that did change their behavior. So this is actually from a press release they had. In light of the results from a recent study by Privacy Grade, Halfbrick, who makes Fruit Ninja and Jetpack Joyride, is going to still greater lengths to inform players about what data the game is collecting during the in-game experience and why. And they also did reduce the amount of permissions that they were collecting too. Whether other developers also followed suit, it's not clear to us because they haven't necessarily informed us. So next part I'll talk about is using text mining to infer privacy-related app behaviors. Does anyone have any questions before going on to the next part?
So how many of the B2A grade changes happened because of the FTC fines? Do you know how many fines were imposed?
Oh, yeah. The way the FTC works is they work by using a very large club. And so what they do is this is just their style of work. They find one egregious violator of their policies and they whack it really, really hard, and then they assume everybody else is going to follow suit. So this is what they did with Brightest Flashlight is they did a pretty large fine on them. I think they also reduced the fine afterwards too. And then assume that other people will see, oh, we might want to pay attention to what they're doing and make sure we don't do the same thing. So whether multiple apps change their behaviors, again, it's hard for us to tell cause and effect. But that's their general style of the work that they do. Okay, so the next part I'll talk about is using text mining to infer privacy-related app behaviors. And the basic idea here is what I've been alluding to. Can we infer the purpose of the custom written code inside of an app? And in general, this is a very, very hard problem because if we could do this, then we could also find all the malware out there easily. We could also do automated testing easily. We could also do program correctness easily. So as you can see, these are all unsolved problems. So what we're trying to do is can we just do our best guess and see how well we can also do that using some machine learning techniques. And the basic insight we have here is that if you look at compiled Java code, it actually still retains a lot of strings inside of it which we can use to infer the purpose. And so here's a concrete example of this. Let's say that an app uses location data. And if we decompile the app and we see a whole bunch of strings inside of it that say things like exif or photo or tag, then you could probably guess with pretty high accuracy that it's probably doing geotagging inside of the app because people will probably not name their variables things like this or their method names like this. Okay. And so, like good computer scientists or if you're really good kind of security mindset, you're probably thinking, well, what about the cases where this doesn't work? So obfuscated code is obvious case. So it turns out that roughly 10% of the apps inside of our study were obfuscated. So we can't do anything with those. Deliberate manipulation. So our working assumption is that app developers had no reason to do deliberate manipulation in this current study. In future cases, they might do it, but I think it's a safe assumption that most developers won't be doing this. And the other one is if you've ever seen code, you've probably seen really bad variable names too, like A1, A2, V1, and so on. So yes, this does make our life very painful. But this technique still works better than you might expect in most cases because humans generally still have to name their classes pretty good things, even if they don't name their variables good things. So what we did is we gathered and decompiled 622 apps, only ones that were using find location and reading the contact list, and we manually labeled and clustered by purposes based on app description and code. So the text description on Google Play as well as the code that we can inspect. And here's the different permissions that we had. So by location permission, we've actually expanded the number of categories that we had too. So for example, for location permission, we have nearby places. So find me nearby restaurants, for example. Location-based customization, turn off my phone when I go home, or things like that. Turn off Wi-Fi or turn on Wi-Fi when I go to other places. Traffic information and so on. On the right side, here's the categories we came up with: contacts permission. So backup and synchronization is a really popular one. Contact management, so helping me manage all my contact lists. My favorite one is actually number 9, fake calls and SMS. So this is in the case you're in a bad date, and then you can set it up, so call me in 10 minutes, and then you can try to get out of the bad date. There's also a few apps that we just couldn't figure out at all. It was just really complex code, and we couldn't figure out what they were doing with location data. So not a great sign, but this is actually a very rare case. Here's the general system architecture. So we take all these apps, we decompile them, we identify where in the code it was using sensitive permissions, so location data, contact list. We do a lot of machine learning extraction feature extractions there, and then we train a classifier too. Again, we're just looking at the custom code, not for the libraries, because we're looking at sort of the new part that we didn't know how to do yet. So here's some more details if you're interested. So we use APK tool to decompile to Smalley, which is intermediate code. This was helpful for us to identify which parts of the code use location or contact list, because there's actually a well-known mapping that says, well, if you're using this method, that means you're using location data. I'll talk about that in the next step, actually. Then we use dex2jar and this other library, JD-Core, so the tool JD-Core Java, to decompile the Java source code. This is what we use to extract the features. For identifying the permission-related code, we use a technique similar to a tool called pscout, and this was published at CCS back in 2012, the security conference. basically, again, they just had a gigantic map of methods saying that this method, if you call this method, that means it's going to use contact list. If you use this method, it's going to use location data and so on. So we just use that simple mapping and just look for the methods that were called. For the granularity, we use the package as the granularity of code. The reason for this is that a package is just generally a directory, so a combination of source code that is sort of somewhat cohesive. The reason for that is because individual Java files tended not to have enough semantic information to do the analysis for us, so we tried to expand it a little bit more to the package level. For the third step, we extracted all these features. We have two different categories. The first one is app-specific features. So we created a feature vector of 680 permission-related APIs, so that's from the mapping I mentioned in the previous section, 97 intents and 78 content providers. And so again, just to convey the intuition, if you see that it's using contact list plus the email activity, it's probably using it for email. And if you're using the contact permission plus sending SMS APIs, you can probably guess what it's doing as well too.
So does that mean the dimensionality of the system is somewhere around 900 and you have 600 training examples?
No, it's 680 feature vector. So just 680. No, actually you're right. It's 600, 700, 800. So yeah, about 800.
You're vastly sparse.
Yeah, and unfortunately it is sparse. But the next part actually helps us too, which is trying to extract the strings from the identifiers. So in some ways this part is also sparse too, but in terms of the cross-fault validation, it actually worked pretty well. That's a very good point. So what we did was we extracted the strings from the identifiers. So it turns out that in Java, the package names, classes, methods, and field names are kept. So this includes constants and class variables. Unfortunately, probably the most valuable ones, the local variables and parameter names, are not preserved. So this is sort of unfortunate for us. We used a whole bunch of heuristics to split the identifiers into individual words. So for example, find restaurant would be split into find and restaurant. We use stemming, dictionaries, and a whole bunch of heuristics to do that. And we also use TF-IDF to score each word too, to try to figure out how common that word is relative to all the other words that were out there inside the entire data set. In terms of how well it actually works, so maximum entropy actually works out the best in terms of the accuracy. So just highlighting here, so 85% for location use and 94% for context. So generally context was easier for us to guess what the behaviors were inside of it. If we look at the specific categories for the purposes, this would have been better for animation, but the ones that are highlighted, the 78% there for the F measure, I should probably explain for the people who don't know. F measure is basically, it's sort of like the harmonic mean of, I believe it's the harmonic mean of the precision and recall.
Yeah, that's right.
Yeah, so it's basically higher is better for all the numbers here, is the main thing to keep in mind. And so you can see the F measure for searching nearby places is sort of decent, 78%. Location customization and transportation is much higher, so 95%, and recording is much lower too, 77%. And I'll give sort of some insights as to why we think that's the case later on, like why it sort of fails in some cases. For contact lists, it actually does much better, as you can see. The worst case is actually the contact management, about 81% too. And so in cases where this fails, we found that basically this really generic words are the case where it just does not work very well. So we had one app that was searching for nearby places and had top keywords of local, search, place, and find. And these are just generic words that almost all the apps would use for a lot of their kinds of functionality. So this one was misclassified as geosocial networking. And so in most of the cases where we saw that, where it failed, it tended to have this problem. The other problem is, as you were sort of alluding to, is that when there are cases where there are just very few features inside of it, so it just used very few APIs and also had very few keywords and simple functionality. We also misclassified those as well too. But as you can also imagine, the more features there were, the more words, much better it did. We also saw a few odd design patterns, which made our life much harder too. So we found some design patterns where some apps have one object that periodically gets location data, and then you have other parts of the app that are requesting data from that one app, that one object. So basically, they're using a level of indirection. And so in that case, we actually don't succeed because we don't really know where the location is going because we were just doing simple static analysis right now. Okay, so again, that's just sort of the high-level view of that. Does anyone have any questions about that part of the work? We'll get to the end.
Did you take into account things that, like, the idea of local is often used in a software engineering context?
You mean locality, or you mean the word?
So you were talking about like the word local, yeah.
Yeah. So I guess I'm trying to think. Do people use that inside of method names or class names?
I could imagine.
Yeah, that's probably true. Yeah, I think that probably would have been. Let me think. that probably would have been penalized based on the TDF IDF if lots of people do that. But I could still see that being a potential problem. So trying to figure out, we did actually try LDA approaches to start out with, but that didn't work out as well as we were hoping. But now I think about it, we might want to resurrect that idea to help us understand. If you see the word local in certain contexts, it's probably more likely to mean like local search versus local variables. Yeah, that's a good observation.
How do the strings that are not related to the purpose enter into this? Like, so the strings that are in an ad library, for example.
Oh yeah, so we're not analyzing the libraries. That is an idea that we're thinking of doing next to see if we can automatically categorize the purpose of these libraries. But for those other strings, they tend to end up being noise because of the TF-IDF. There's nothing to really classify it on.
Okay.
Okay, so I'll wrap up with some more reflections on privacy ecosystem, and a lot of this was stuff I've been alluding to. Is that we should really consider the entire ecosystem for privacy here too. Most of the research in the community has been focusing on end users, I would say. The user interfaces for it, understanding their preferences, and so on. I'm actually becoming increasingly skeptical of that over time as to the end users because it just puts too much burden on the end users, and I think it also puts it sort of gives, I would say, developers an easy way out. It's like, well, we have this gigantic privacy policy, and they can just read that. And I think we all know that's just really ineffective. It's also really hard to change people's awareness, knowledge, and motivation as well, too, with respect to privacy. I have another paper I can also tell you about this, too, where we're using social psychology techniques to try to improve these things. But in general, it's just really, really hard to try to change people's behaviors. And it's sort of rational because, reading this gigantic privacy policy is a known cost for unknown benefit. And so it's very rational for people not to really focus too much on it. Instead, I think we should focus a lot more on these other parts of the ecosystem, like the developers, third-party developers, markets, OS, and third-party advocates. So I'll talk more about the developers on the next slide, and third-party developers too. The markets is also an obvious place where I'm sure you guys are also doing a lot on that too, and same with the operating system. The challenge there is that these kinds of solutions had to be very generic that work across lots of different kinds of apps. And I'm not sure that they're going to work really well for these really narrow apps that tend to collect lots of data because it's just going to be hard to know that that's what's going on. Third-party advocates, I think, is also pretty promising. The FTC, for example, I mentioned is a good one. I've also met with Consumer Reports too, and I think that's also a really good kind of area for improving things because trusted third party where it can also try to rate these things. The problem with FTC and Consumer Reports though is that the current approach is very manual and labor intensive. So for the FTC, they just have an army of lawyers, and they, for example, the ones who are trying to find violations of COPPA, the Children's Online Privacy Protection Act, they're just manually inspecting lots of apps, and they can only do like maybe a dozen or so per day to try to understand what's going on. And as you can see, they're just outnumbered vastly, and it's just not going to work out. And the other problem with the FTC, which they're currently trying to rectify, is that, again, it's all lawyers, and now they're trying to get some software developers to help them extend the kind of analysis that they can do. But that's still sort of a long-term kind of problem they're trying to address. I think that helping developers is the greatest point of leverage, and this is really the main theme of the work that my team is trying to do more of moving forward. So examples would be better understanding of third-party libraries. So this could be, you can imagine better summaries and for developers to understand, well, if you use this library, here's the kinds of challenges. Here's how you might be able to configure the library so that it does the right thing, so you're not violating COPPA or other kinds of things. I think better design patterns for privacy would also help out a lot. So you can imagine there's lots of guidelines, but there's nothing like having a lot of design patterns saying, here's how you should structure your code, or if you're collecting this data, here's different ways of dealing with it. And I think that would help out a lot too. Better APIs is also something my team's been looking at right now. So you can imagine that if an app was asking you, are you at home or work, just those two locations, and if the operating system could help mediate that, versus tell me your current location, and then I'm going to infer whether it's home or work. So here's a place where I think the OS could offer a lot of support, and if we can figure out better levels of abstractions, I think this would be really good too. And so just roughly the current idea we're thinking of is, what if we had tiers of abstraction? So tier 1 might be, well, full data, and this is the most sensitive data. And tier 3 or 4 might be, here's the least sensitive data from what we can tell. Like, you're at home, you're at work, you're out traveling. And then you could also, if we had these different tiers of APIs, we could start categorizing, well, you're actually collecting lots of data. We might suggest you use some of these other APIs instead. And so this might also help us infer the privacy grade as well, too. So it's sort of an abstract idea, but we're trying to figure out ways of operationalizing it. The other one, too, I would say is, I think, pretty interesting, but also not clear how to operationalize yet, is if we have better reusable components. So one of the things I find really fascinating about databases is there's a set of properties they have called ACID. ACID stands for atomic, consistent, isolated, and durable. And the really beautiful thing is that you, as a developer, don't have to know anything about databases and these properties, and you get them all for free. So if we could identify useful properties inside of data collection or inside of how the data is manipulated, and we can build it into the most common kinds of open source tools that people would use, then we could also start nudging people towards privacy to make it the path of least resistance. So again, the developers already have a lot of burden right now, so we can streamline things and make it really easy to do. So another concrete example is the graphical user interface. You don't have to know much about how graphical user interface widgets work. You just have to grab, here's a button, here's a checkbox, here's this other thing, and it just makes it really easy, and then it also makes the interfaces more reliable as well, too. So, and it made the path of least resistance the easy thing to do for, and the right thing to do for the vast majority of cases. Okay, so that's pretty much it for the talk. So I want to thank everybody. So two of the people here, at least, are on the call, so Shah and Jiayu. Kevin Koo is also an intern here at Google this summer, so I'll also say you guys were really smart to hire him, and he's really fantastic. He helped us do a lot of the analysis and updates of the crawl. Song, he just graduated, so you guys were also smart enough to give him an offer, but he decided to go to Uber instead, so I'm sorry to say that. Barry Wash is also the person who created the mobile app as well, too. And special thanks to all the funders, and also would say Google has been very generous in the funding, and I would also like to thank you guys for that. All right, thank you, and happy to answer any questions you guys may have.
Yeah, so you said that one of the areas that were potentially fruitful would be helping developers. And you talked earlier about how developers often don't understand what's going on in the libraries that they're using. How big is that problem? Because if the developers, if only a few of them don't understand the problems, and helping them understand it won't help that much.
Yeah.
If it's the case that most developers do understand what's going on and they're happily selling your privacy because their motivations are mixed compared to users.
Yeah,
about that?
I think that's a great question. From what I can tell, developers have a vague idea that there's data collection going on, but they have no idea to what extent, how to configure it. And again, their main motivation is just to, let's get it out there, and then, oh, we need to make money. Let's grab this ad library. What's the simplest thing we do? All right, let's do that. We've seen that kind of pattern very, very often. And I would say, there's definitely a long tail of developers. There's some that can devote lots of time to understand this, but the vast majority, I think, can't. And so if there's better ways of helping them integrate this, like I can imagine better tools for clips maybe that might suggest, here's what's going on with the data, or maybe suggesting different libraries, or even understanding kappa as well too. Because I think, again, they sort of have this vague notion that something's wrong, but just don't know what to do about it. And I think that was pretty universal across all the interviews, and I'm not sure if that's really supported by the quantitative data though.
Yeah, our experience has been that a lot of the questionable behavior we've seen on behalf of otherwise innocuous apps has been on behalf of, say, an ad library pulling in far more than we would be comfortable with.
Yeah. Yeah, we've also seen some newer behaviors by some ad libraries where they're trying to get more of the developers involved, and we're not entirely sure why. I think it's probably to try to shift the blame from the libraries to the developers. So, for example, they ask you to get the location data and then send it to the library. Mm-hmm. But again, the developers, they might get a sense as to, well, something's weird, but we also want to make money. So the garden path is, okay, let's just do it, without fully understanding what's going on.
I thought you said you rate the libraries as well.
We don't do that yet. We've been thinking about that, and that's also a commonly requested feature by some of the end users as well as by the FTC. We're not sure of what method we would use yet. We have some ideas, but we're not sure how to execute on it yet. But if you guys have great ideas,
because that would be a very clear win to a developer
exactly.
To say this library and this library don't both do the same thing.
Exactly.
Toss together a couple apps, integrate the libraries, A/B testing done.
Two great tastes that taste great together.
So, Jason, can you hear me?
Yes.
So I'm wondering about what's the sort of full scope of things you're hoping developers will do. So clearly you're trying to motivate them to maybe be smart about the ad library they pick, and you're trying to motivate them to use fewer permissions, only the ones they might really need. What else is it that you hope they will do as a result of this?
Yeah, I'm hoping that they'll be able to make good trade-offs is really the main thing. When we've also seen that in some of our studies, this is one's conducted by Jiayu, that if people also have a better understanding of what's going on with the data, then they tend to be more comfortable with it. So even if it's being location data or other stuff is being used for advertising, as long as they see the trade-off there, then that's also good. And so another one I didn't mention, because it's partly end user and partly developer, is if we can develop better interfaces that can help convey to people. But it's not really, again, the end user part, I don't want to put the burden on them, but by having that transparency, I think that helps the developers do better, and also can help with the FTC and consumer reports and other kinds of things too. So that's part of my goal too, is to get them thinking a little bit more about this and make the tools easier to use. Where, again, the garden path is the safer path with respect to privacy. But I also have emphasized every time I talk to journalists too that the app market is thriving primarily because we have all these free apps, and so we don't want to destroy this ecosystem either. So we want to make sure that we can have wins for everybody inside of this. I'm not sure if that really fully answers your question.
Yeah, that's good. Yeah.
Yeah, I have a question. Yeah, I mean, I like to say the static analysis have some limitation because even though developers include those as library in their application, but they tend to just disable it, and jar file or the static analysis will just still there, but if application is not actually invoking it. But if we penalize based on the having those libraries there, and they do not execute it, it's very hard to penalize you are doing the.
Yeah, that's a good point too. Yeah, I should have added that to our limitations, that we're not actually checking if all the most egregious functions are invoked, that they might be using a less egregious one. So it is a sort of an approximation. One thing we've also thought about for developers too is that if you're using this library, consider using this other API, the less egregious one versus the more egregious one. But we haven't figured out how to do that at scale. And we can do that for individual libraries. But yeah, that's a really good point too.
So sort of a related question. Have you started looking at the network behavior of the apps to see whether they're actually sending the data off the device or which domains they're communicating with?
Yeah, so we're not doing that yet. Part of the challenge there is that we have looked at doing dynamic analysis. What we discovered is running the Android emulator really sort of, I wouldn't say cripples. You can only run one emulator on the phone, on your laptop at a time. We tried running multiple ones on virtual machines. Shah was the person who did that. And found out that you can only run one or two virtual machines on your device, on your laptop or a computer before. That's pretty much all you can really do. And so we figured it would be really hard to do that at scale. We do have monkey apps that we've created some pretty good ones that can try to traverse all the different screens and capture that data too. I think that probably the right approach for privacy analysis is that, from Google's perspective, is that you probably want a thin layer that does shallow analysis across all the apps, and then you probably want deep analysis where you do have human in the loop across the most popular apps, and that's probably going to be the best cost benefit. And so Shah, he did for his dissertation work a tool that helps you do that kind of deep analysis. So it runs all the different screens for you. It tries to capture, here's what data is being sent out, and it happened because you clicked on this button. And then you can help the analyst through a lot of heuristics too. So this seems to be odd behavior. It's an app that only calls one phone number, sort of odd behavior. Or it uses this combination of permissions, which is also potentially unusual behavior. And so by helping to focus the analyst's attention at the right places. So yeah, we have thought about that. I'm also thinking about doing that for Internet of Things as well too, to help understand from the network analysis what kind of data is being sent across. Of course, the challenge is that once they use SSL, then that makes it incredibly difficult to do.
Right, but you'd be surprised how few of them do that.
Yeah, we also know that too. Yeah, in fact, that's one.
I don't think that's going to be a major hindrance to that.
Yeah, that's one of the heuristics that Shah also had in his work too. It's like app doesn't use SSL properly, which is easy to find.
I wonder if there isn't another library that you've missed analyzing that's right there, which is the TOS libraries encoded in a language called legalese. Could these bag of words techniques, information retrieval techniques, also be used to analyze that at scale that you can't do if you individually try to read them?
It's funny you mentioned that because that's one of the projects we are currently working on. The basic idea, I don't know if you know what the website Kitten War is. If you don't know what Kitten War is, you will love it if you like cats. And if you don't like cats, go to Puppy War instead. and the basic idea is it's A-B, right? So it's like, which cat is cuter, A or B? Repeat. Which cat is cuter, A or B? Repeat. And eventually, you can actually see the winningest cats and the losingest cats. And we're applying the same idea to privacy policies too. So we're like, which thing is more important to know? The site, we care about privacy, or we will use this data and for these purposes. Right? And so based off of that, we're trying to create a predictive model as to what kinds of things tend to go to the top. We actually, in our preliminary results, we haven't published this yet, which is why I didn't talk about it here. In our preliminary results, we tried on Google's privacy policy, and things like, Google really cares about their privacy policy, or privacy, just goes straight to the bottom. No one cares about this. And things like Google might use, your call data for X. That goes straight to the top. Location data also goes straight to the top as well, too. And so we are trying to look at creating the predictive model, and then we are looking to augment privacy grade with those privacy policies as well, too, the summaries of them, and also looking at how we can put it inside the web browser for Chrome and other kinds of things. But we're still sort of in the, we're maybe like a third of the way through the research. We've tried a few iterations. We found things that don't work, a lot of things that don't work. But we have found a few things that do seem to work. And we're also looking to try to see if we can add in ELO ratings and other kinds of things too. So because if you have like 100, if you have 10 statements, then 10 choose 2 is actually not that big. But if you have 100 statements, it's pretty big. And so we also have to try to figure out, be judicious in terms of the crowdsourcing of A/B testing there. So the short answer is yes. And I'm really glad you thought of that, because
But most of these developers, they are small people, they don't have lawyers working for them, so they most likely might just copy paste the developer policy of a popular app and use their own app.
Yeah, I'm pretty sure that happens too. In fact, we're starting, actually we haven't done that yet, but I want to hire someone to crawl lots of privacy policies, and we can sort of see the genetics of those as well too. I'm pretty sure they are copied and pasted a lot. But yeah, we also want to just crawl the privacy policies so that we can start trying to see the changes over time and also do a lot more of the A/B testing.
Mm-hmm. And when you started grading these apps, did you receive any complaints from the app developers saying, how could you give us this low rating?
Oh, surprisingly, no. The only request for takedown, everyone for requesting takedown has been very polite. One requested for copyright reasons that because of their text description. Right, so it's like, all right, fine. Another one is when we looked at it, we thought that there were probably errors in our analysis. So we actually, one thing I didn't mention, we actually don't put grades on antivirus because they just use lots of permissions, and it's pretty clear that they're not using for malicious purposes. But according to our model, it would, we get a pretty low grade, so we just removed those off the bat because of the accuracy. And then, let's see, I'm trying to remember what the other request was. Yeah, there was another one too, but it wasn't for grade reasons. But yeah, we actually have had a little feedback from developers too. I find that a little bit surprising, but I figured they just also take the garden path. It's like, oh, all right, let's just change our app or rename it or re-upload it or do something.
Mm-hmm.
So Jason, does privacy grade do anything like let people who come and look at the grades for all the apps that have the same functionality sort of next to each other? Like I can just search for all the flashlight apps and look at them side by side? Because that way I can pick the one with the best grade. It would make it like easy for people to make those decisions.
Right. So right now it only offers a keyword search rather than functionality search because we're not sure how we can do the functionality search. We have thought about how to add recommended apps, and so we might show instead of the Google Play recommendations, we might show other recommendations. I did have a summer intern working on that last summer, but we've just been short on resources because unfortunately almost everyone on that list is graduating or has graduated. So I am actually looking to hire 3 PhD students in this fall and see how we can continue things. But yeah, so the short answer is sort of.
Okay.
Okay, so I'll be around for the rest of the day, so happy to chat with the rest of you guys. Thank you very much, and if you have any more feedback, please feel free to send to me.
Thank you very much.
Thank you.